The world is changing at an unprecedented pace, with innovations and breakthroughs happening almost daily. We are witnessing the dawn of a new era, driven by rapid technological advancements that are reshaping every aspect of our lives. This era, known as the Fourth Industrial Revolution, or Industry 4.0, is transforming the way we live, work, and interact with each other, creating a world that is more interconnected and intelligent. It is a revolution built on the foundations of the past, but with the potential to reshape our future in ways we can only begin to imagine. The innovations of today are paving the way for a future that is more efficient, sustainable, and inclusive. The first industrial revolution harnessed the power of steam, mechanizing production, and laying the groundwork for modern industry. The second industrial revolution introduced electricity and mass production, forever changing the industrial landscape and enabling the mass production of goods. The third industrial revolution brought us computers and the internet, ushering in the digital age and revolutionizing communication and information sharing. Now, Industry 4.0 is taking these advancements further, blurring the lines between the physical, digital, and biological worlds, and creating new opportunities for innovation and growth. This new era is characterized by the fusion of technologies like artificial intelligence, the Internet of Things, and cyber-physical systems, which are transforming industries and creating new possibilities. These technologies are converging to create intelligent networks, capable of communicating and collaborating with each other, making decisions and taking actions with minimal human intervention. This level of automation and intelligence is unprecedented and is opening up new frontiers in efficiency and productivity. The possibilities are limitless, and the impact of Industry 4.0 is being felt across all sectors, from manufacturing and healthcare to transportation and energy. As we continue to innovate and push the boundaries of what is possible, we are creating a future that is more connected, intelligent, and sustainable than ever before. To truly understand the significance of Industry 4.0, we must first look back at the revolutions that preceded it. These revolutions have shaped the world we live in today, laying the groundwork for the technological advancements we now take for granted. Each revolution brought about profound changes, not just in technology, but also in society, economics, and the way we live our lives. They redefined human potential and altered the course of history in ways that were unimaginable before their time. The first industrial revolution, beginning in the late 18th century, marked a turning point in human history. It was a period of great innovation and transformation where manual labor began to be replaced by machines. The invention of the steam engine and the mechanization of production led to a surge in productivity, the growth of factories, and the rise of cities. This era saw the birth of the modern industrial city, with its bustling factories and crowded streets. However, it also brought about social challenges such as poor working conditions and income inequality. Workers toiled long hours in dangerous environments, and the gap between the rich and the poor widened significantly. The second industrial revolution, which began in the late 19th century, was characterized by the introduction of electricity, mass production, and the assembly line. These innovations revolutionized manufacturing processes and led to unprecedented economic growth. These innovations led to even greater increases in productivity, the rise of large corporations, and the growth of global trade. The world became more interconnected, and industries expanded their reach across continents. This era also saw the emergence of new industries such as automobiles and chemicals. These industries not only transformed transportation and manufacturing, but also had a profound impact on everyday life. The third industrial revolution, beginning in the mid-20th century, saw the rise of electronics, computers, and the internet. This digital revolution brought about a new era of information and communication technology. This digital revolution transformed communication, information processing, and automation. It enabled the rapid exchange of information and laid the foundation for the interconnected world we live in today. It led to the globalization of information and the creation of new industries such as software and e-commerce. These industries have reshaped the global economy and changed the way we conduct business and interact with one another. Each of these revolutions brought about significant advancements, but also presented new challenges. They force society to adapt to new realities and address the unintended consequences of rapid technological change. Industry 4.0 is no different. It represents the next phase of industrial evolution, characterized by the integration of cyber-physical systems, the Internet of Things, and artificial intelligence into manufacturing processes. While it offers tremendous opportunities for progress, it also requires us to address complex issues related to job displacement, cybersecurity, and ethical considerations. As we navigate this new era, it is crucial to learn from the past and ensure that the benefits of technological advancements are shared by all. At the heart of Industry 4.0 lies a convergence of powerful technologies that are reshaping the industrial landscape. These technologies, including artificial intelligence, the Internet of Things, and cyber-physical systems, are the pillars upon which this new era is built. Artificial intelligence empowers machines to learn from data, identify patterns, and make decisions with minimal human intervention. AI algorithms can analyze vast amounts of data from various sources, enabling businesses to optimize processes, improve efficiency, and personalize customer experiences. The Internet of Things connects everyday objects to the Internet, allowing them to collect and exchange data. This interconnectedness enables real-time monitoring, remote control, and data-driven insights. From smart homes to connected factories, the IoT is transforming the way we live and work. Cyber-physical systems bridge the gap between the physical and digital worlds. These systems integrate sensors, actuators, and computational elements to monitor and control physical processes. This integration enables real-time data collection, analysis, and feedback, leading to more efficient and responsive systems. Section 4. The rise of the smart factory. One of the most significant manifestations of Industry 4.0 is the emergence of the smart factory. These advanced manufacturing facilities represent a new era in industrial production, where technology and innovation converge to create highly efficient and adaptable environments. These factories of the future leverage advanced technologies to optimize production processes, enhance efficiency, and create more agile and responsive manufacturing environments. By integrating cutting-edge tools such as robotics, artificial intelligence, and the Internet of Things, smart factories are revolutionizing the way products are made. In a smart factory, machines are interconnected and communicate with each other, sharing data and coordinating tasks in real time. This seamless communication network ensures that every part of the production process is synchronized and operating at peak efficiency. Sensors collect data on various parameters such as temperature, pressure, and vibration, providing valuable insights into the production process. These sensors act as the eyes and ears of the factory, constantly monitoring conditions and feeding information back to central systems. AI algorithms analyze this data to identify patterns, predict potential issues, and optimize machine performance. By leveraging machine learning and predictive analytics, smart factories can anticipate problems before they occur and make adjustments to maintain smooth operations. This interconnectedness and data-driven decision-making enables smart factories to achieve unprecedented levels of efficiency. The ability to make informed decisions quickly and accurately is a key advantage of these advanced manufacturing environments. Production lines can be adjusted in real time to accommodate changes in demand, raw material availability, or equipment performance. This flexibility allows manufacturers to be more responsive and adaptive, ensuring that production can continue smoothly, even in the face of unexpected challenges. This agility allows manufacturers to respond quickly to market fluctuations and customer needs in a rapidly changing global market. The ability to pivot and adapt is crucial for maintaining a competitive edge. Moreover, smart factories can significantly reduce downtime by predicting and preventing equipment failures. Predictive maintenance strategies use data and analytics to foresee potential issues and address them before they lead to costly interruptions. Sensors can detect anomalies in machine performance, alerting maintenance teams to potential issues before they escalate into costly breakdowns. This proactive approach to maintenance ensures that equipment remains in optimal condition and production is not disrupted. This predictive maintenance approach minimizes production disruptions and extends the lifespan of equipment. By keeping machinery in top working order, smart factories can maintain high levels of productivity and efficiency over the long term. Section 5. A symphony of customization. In the past, mass production was the dominant manufacturing paradigm. However, Industry 4.0 is ushering in an era of mass customization, where products are tailored to individual customer preferences without compromising efficiency. Smart factories, with their flexible and adaptable production lines, are ideally suited for mass customization. They can quickly adjust production parameters to create personalized products even in small batches. This capability allows manufacturers to cater to the growing demand for unique and customized goods. Advanced technologies such as three-dimensional printing further enhance mass customization capabilities. Three-dimensional printers can create complex designs with intricate details, allowing manufacturers to produce highly customized products on demand. This technology eliminates the need for expensive tooling and reduces material waste. Mass customization offers numerous benefits for both businesses and consumers. Businesses can differentiate themselves from competitors by offering unique products that meet specific customer needs. Consumers, on the other hand, benefit from personalized products that cater to their individual preferences and requirements.